This video is going to cover the Mantel-Haenszel method of calculating an adjusted odds ratio with one confounder that's categorical. So the situation where you can use the Mantel-Haenszel method for this is when the outcome is binary, like in a case control study, when the exposure is binary, and when you have a binary confounder. And the basic idea, if you think sex is a confounder, for example, you can find a adjusted Mantel-Haenszel odds ratio as a weighted average of the odds ratio in the male strata and the odds ratio in the female strata. So for the rest of the video, this is kind of the notation I'm going to be talking about. I'm not going to go over each of these individually, but basically we have A, B, C, and D that talk about that represent the various combinations of exposure and case status. And we also have these marginal totals, so like all of the exposed people, all of the unexposed people, all the cases, all the controls, and the grand total, which is all four added up. So this table can be stratified into the same information, but this table only has males and this table only has females, and that's what you can use to calculate strata-specific odds ratios. So the formula for the Mantel-Haenszel odds ratio, I'm just going to talk about the numerator and then the denominator. For the first strata, you would find the product of the exposed cases and the unexposed controls, A and D, and divide by the total number of people in that strata. And then you would do the same for the other strata and sum the two. And then in the denominator, you multiply B by C, so these two cells, the unexposed controls and the exposed controls and the unexposed cases. And then you would do that for the other strata and sum that. And yeah, that's basically what it would look like if your confounder is males and females, where you would do the same thing for males and females and then add, and then the same thing in the denominator and add. And this is basically a weighted average of the odds ratio for each strata. So the example I'm going to use is if we're interested in the influence of fatty diet on liver disease and we think alcohol might confound this relationship, what we can do is first calculate the crude estimate. So this is just our exposure of interest and outcome of interest, so fatty diet and liver disease. And we have the distribution that would let us calculate crude odds ratio, so 50 over 35 divided by 5 over 10, it comes out to 2.9. We can also stratify by alcohol intake, so you'll notice there was 100 individuals in the crude estimate, but if we know that 50 of them consume high alcohol and 50 of them consume low alcohol, right now those individuals that consume high alcohol and low alcohol are scattered throughout this table. But if we separate them into the 50 that consume high alcohol and the 50 that consume low alcohol, we're able to calculate the stratum-specific odds ratio. So here we can calculate the odds ratio among those who consume high alcohol, so 19 over 18 divided by 6 over 7 comes out to 1.2. And same with low alcohol, so 21 over 20 divided by 4 over 5, so it comes out to 1.3. And we can also calculate the Mantel-Haenszel odds ratio. So we have A times D, so 19 times 7 divided by the total in 50, and we do the same for the other stratum. So A times D, so 21 times 5 divided by 50, that's the total number in the low alcohol stratum. And then in the denominator, we have B times C, so 18 times 6 divided by the total number in that stratum. Same with low alcohol, 20 times 4 divided by the total number in that stratum. It's kind of repetitive, but yeah, and that would come out to an Mantel-Haenszel adjusted odds ratio of 1.26. So taking this information together, we can see that the Mantel-Haenszel odds ratio sits kind of in between the stratum-specific odds ratio, and if the reason it's so close to almost like exactly half is because we had the same number of people, and if there was a lot more people in one stratum than another, it would weight differently. And yeah, one of the major assumptions here is that the measure of effect, so the odds ratio in the two strata of the confounder, are similar. So here we have 1.2 and 1.3, and that's really pretty close. If they were super different, like say in the high alcohol strata it's 7.2 and in the low alcohol strata it's 1.3, that would be an indication that there is effect modification happening here, where the relationship between liver disease and relationship, what was our, yeah, relationship between fatty diet and liver disease is different among the two strata of alcohol. That would be an indication that alcohol is modifying the effect of fatty diet on liver disease. So this is typically where people would stop, where they say, okay, so the measure of effect in the two strata of the confounder are similar, so there's no effect modification happening here. And the Mantel-Haenszel odds ratio is pretty different from the crude odds ratio, so that tells us that there's probably confounding happening. But if you want to make sure, you can do a chi-squared test to test both of these things, that these are similar and that these are different. And I'll just go over that quickly. So it's kind of cumbersome, but yeah, so this is the chi-squared statistic for seeing if 1.2 is different enough from 1.3 to say there's effect modification, or if they're similar enough to say that there's no effect modification. So yeah, it would be the sum for the two stratums. So in the first stratum, it would be the ln odds ratio in that stratum minus the Mantel-Haenszel odds ratio, ln transformed, divided by the variance of that estimate of the odds ratio in that stratum. So I'm going to go over this with an example. This is the one thing we don't have, basically, is the variance. So what we would do is divide by pretty much add the reciprocal of each cell in that stratum. So back in our example, we have our high alcohol stratum. We can find the variance of that estimate by just adding the reciprocal of each of these cells, and we get an estimate of the variance there, and we can do the same over here. And now we have everything to find that chi-squared statistic. So the ln odds ratio in the high alcohol strata is 1.2, and then the Mantel-Haenszel odds ratio is 1.26, that's squared, and then divided by the variance of that estimated strata-specific odds ratio, so 0.42, and we do the same for the low alcohol strata, and we get a chi-squared statistic of 0.008, and we have 2 rows and 2 columns that went into this calculation, so 1 degree of freedom. So the critical value there is 3.8, and our statistic is much lower, so that tells us that there's not evidence that these two numbers are very different, and we can be confident that there is no interaction. If, however, we found that there was evidence of an interaction, there would be no reason to continue, and you wouldn't use the Mantel-Haenszel odds ratio, because it would be evidence that there's not confounding happening but effect modification. And in that case, you should carry on with the analysis and the description of the data, talking about these two things separately, basically. But since we found out there was no interaction, we can move on to the next step and see if our Mantel-Haenszel odds ratio is significantly different from the crude odds ratio, where everything was pooled by alcohol, and we're basically seeing if when you adjust for alcohol, if the measure of effect is different enough to be considered having been confounded by alcohol. So the chi-squared statistic for that Mantel-Haenszel odds ratio is the sum of the exposed case cells in the two strata minus the expected value for that cell, and I'll show you how to find that, and then the sum of the variance in the two strata. So the expected value in this cell is basically the marginal total of exposed multiplied by the marginal total of cases and divided by the grand total. And the variance of that estimate of the A there is that you would multiply the marginal total for exposed, unexposed cases and controls, so multiplying all of the marginal totals, and then you would divide by the grand total squared times the grand total minus 1. So going through that with our example here, to find what we expect to be in this cell, we multiply the marginal total for the exposed group by the marginal total for cases, so 37 multiplied by 25 divided by the grand total of 50. So we get an expected value of 18.5, which is pretty close to 19. And we do the same for the low alcohol group. 41 times 25 divided by 50, 20.5, also very similar to our expected value. Or to our expected is very similar to our observed value. And now we can calculate the variance of that estimate. So multiplying each of these marginal totals, 37, 13, and the two 25s, and dividing by the grand total squared, multiplied by the grand total minus 1, we get a variance of 2.45. We can do the same on the other side, getting a variance of 1.9. So now we have everything we need to find this Mantel-Haenszel chi-squared statistic. So we would sum the two observed A cells, so 19 and 21, and then we would subtract the two expected ones, so 18.5 and 20.5, and divide by the two variance estimates summed together, so 2.45 plus 1.9. That comes out to 0.23, and this is also 1 degree of freedom, and the critical value is 3.8, so there's not enough evidence here that our Mantel-Haenszel odds ratio is significantly different from the crude odds ratio. In reality, the Mantel-Haenszel odds ratio is probably different enough from the crude to consider confounding, but part of why that probably happened was that the sample size was so low. The effect wasn't actually that different, where like with the Mantel-Haenszel odds ratio, I think it was like 1.2 something, and for the crude one it was 2.9 something, so it was like not extremely different. And combined with how underpowered the study is, I guess it wasn't enough evidence to determine that they were two different numbers. But yeah, ultimately you would probably be using regression to find this, and you'd probably have a much larger sample size. So yeah, but in this scenario, using this method, it would be, if this was the criteria you're using, it would be like what we would settle on is basically that alcohol wasn't a confounder.